Hi everyone, welcome to my channel Design with Rusbe. Continuing with CSWA practice problems, today we'll work on question 2.4. Let's take a look at this question. So in this question, unit of measurement is millimeter gram second. So when we start working in SolidWorks, we need to ensure we are using the same unit of measurement. Now looking at this geometry, we have a symmetric geometry. You can see that we have the 3D model, we have the bottom view, we have the front view, and we have section AA. So when we start working on this part, we need to start from the base of the geometry, which is this bottom view. And what we can do, we can make this geometry with all the dimensions and then use extruded bus feature to make the base of the geometry. The next step after that is focusing on a second part of the geometry, which is this step. And you can see it here. It's exactly same as the first step or the base of the geometry. However, there's a distance between the edge of the second piece and the first piece. In other words, we have the offset between these edges. However, there's an interesting point here that I want to mention. Unfortunately, when I started working on this question, I found that we don't have the offset value defined in this geometry. If you look at the geometry, you can see that we have every single dimensions for defining the base of the geometry. However, if I want to make the second part, I don't see any sort of offset value between the outer edge and the inner edge. And that's going to be an issue because when we work on this question, we want to check our final answer. And without knowing that dimension, it's almost impossible to solve it. And again, this is not a new thing. We've seen many circumstances before in practice problems when we didn't have sufficient information. We made an assumption. But most of the assumptions that we made were related to relationships, not the dimensions. Here we are missing the actual dimension, which can make problem in finding the final answer. So I did my research and I found that there is a more completed version of this question available online, and that's the question I want to share with you. As you can see, this is a question that I found online, and it's quite interesting. Once you look at this question, you notice that you have one more view shown in this question. We have the bottom view, we have the section view, but you can also see the top view. And it's interesting that on the top view, you can see the offset value. You can see that we have C value, which is showing the offset or the distance between the edge of the second piece and the first piece or base of the geometry. So in my opinion, it's forced that we spend time on this question because this question is fully defined, this question has enough information, and we can find the final answer and check it against the answer provided in this question. Also, it's great to work on this question because it gives us the opportunity to use equation-based modeling, which I'll explain for you later. So without further ado, let's focus on this question. Let's jump into SolidWorks and start modeling this part. So in SolidWorks, first thing first, we need to check unit of measurement. And as you can see, we have a correct unit of measurement, which is millimeter gram second. Next step is to model the part. However, this time it's going to be a little bit different because we have equations or global variables in the question. First, we need to define our global variables. So let's check out the question again. In the question, as you can see, there are three variables defined for you: variable A, variable B, and variable C. And you can see that some of the dimensions that we have, for example, the radius of this circle is defined based on a variable. So they're saying the radius of this circle should be equal to A, and A can change. There's actually benefit in using equation-based modeling because whenever you want, instead of changing details in a model, you can simply change these variables and your model will be updated automatically. So let's first start by defining these variables in SolidWorks. In SolidWorks, in order to define variables, you need to have the equation folder here. You can see the equation here. If it's your first time using equation, I'm assuming that you're not seeing equation in your model tree. The way you can add the equation to the model tree is you can right click on the model tree, and then here we have different options. From the options, choose hide and show tree items. And here you can see the equation. Most probably for you, the equation is set to be on automatic. Just change it to show and click on OK. And now you have the equation. Now, right-click on the equation and click on Manage Equation. And now you have Equation Manager. All you need to do is to define those variables. So let's start defining the variable. First variable is A, and then the value is 43 millimeter. Second is B, the value is 18 millimeter. And third variable is C, and the value is 3 millimeter. So now we have these variables defined. Click on OK, and now we are good to go. From now on, everything else is the same. Click on the sketch and choose top plane. And now I want to make the base of my geometry. So to start doing that, let's click on the Sketch tab and then choose Circle. And then here I'm going to make a circle. Now, looking at the geometry in the question, I know that the radius of this circle must be equal to variable A. Now, all I need to do is click on the Smart Dimension, click on the circle, and then here I'm going to add the dimension. I know that diameter is 2 times radius. So what I'm going to have, I click here and 2 times here A. And A is my global variable. Or if you want to make sure that you're using a global variable, you can click A and you can see the variable here. Click on it, times 2 and hit enter. Okay, now we define the diameter of this circle. Next step is to make holes in the geometry. We need 1 hole here, 1 hole here, and 1 hole here. So totally 3 holes. Let's click on circle and I'm gonna make first hole here. Okay, now looking at the question, you can see that the diameter of this hole is 6 millimeters. So I click on the Smart Dimension, I click on the hole, and the diameter is 6 millimeter. Okay, awesome. Now we need 2 more holes. You have 2 options. First approach is to use circle command and then make those holes. We know that the circle is 360 degree. We have 3 holes, so the angle between the holes must be 120 degree. And then you can draw the circle and that's it. Second option is to use circular pattern. So let me show you how to use circular pattern. To do this, click on a sketch, and from the options you can see linear sketch pattern. Click on the drop down menu and choose circular pattern. And then here you can choose the object that you want to use for pattern. So I click on the circle. You see 4 circles total. If you want to change that number, simply click on this box, and that box is basically including number of instances, and change it to 3. And now you can see the preview. Click on OK and you have your circles. Now the question is why these circles are not fully defined. It's always happening. When you use circular pattern, you need to define the location. Now if I click on this circle, center point, you can see I can move it. So clearly this circle and this circle, they're not on these black circles. So what I can do, I can click on the center point, I hold Control, I click on the black circle, and from the options I choose coincident. I repeat this process again. I click on this hole, center point, hold Control, click on a circle, and choose coincident. And now you can see all the circles are fully defined. Okay, great. Next step, we need another circle, larger circle around the holes. So what I can do, I can click on the Sketch tab, choose Circle command, and I can make these circles. Next step is to dimensions these circles. What's the dimension of these circles? Looking at the geometry, we know that the radius of these circles is 15 millimeters. So what I can do, I can click on a Smart Dimension, and then here I define the diameter, which should be 30 millimeter. So I define 30, 30, and 30 millimeter. Okay, great. Now we are almost ready to do the extrusion. We just need to add fillet to the corners that you see. But before that, I want to trim unnecessary lines because it makes my geometry kind of complicated. To remove those lines from this sketch, click on Trim Entities. And I'm going to choose Power Trim. And then here, remove this line, remove this line, remove this line. And also I want to remove this line, and this line. Here, this one, and this one. And finally this, and this is the last line. Okay, so now the next step is to add fillet radius. To do this, we can go to Sketch tab, and then from here I choose Fillet command. We have 7mm radius, and now it's time to select the corners. I select this corner, this one, this one, this one, this one, and this one, and click on OK, and we're good to go. Now we have the fillet radius, everything is ready to use Extruded Bus feature. To do the Extruded Bus feature, click on Feature, go to Extruded Bus, and now here, first of all, we need to change the offset. We don't need offset from surface, we need a blind extrusion. And now we need to define the thickness. What's the thickness that we need? According to the geometry, the thickness should be equal to variable C. So what I can do here, I can hit enter and then equal, and from the global variable I can choose C and then click OK, and now I have my first geometry made. Awesome. So now we go to the next step. Next step is to make second part of the geometry. It's going to be exactly same as the first part, except that we need some offset on the edges. So what I can do, I can click on a sketch, choose a sketch, and I'm going to choose this surface. Now, because we want to have the offset line, all we need to do is to go to the Sketch tab, and then from here I choose Offset Entities. Now here, I select the surface. You can see the preview, right? First of all, the direction is wrong. So what I can do, I can click on Reverse to have the reverse direction. Now, it's quite interesting. You can put global variables in the offset. So if I put equal, you can see that I can put the global variable. So the trick here is that you first define a dimension here, and then you're going to define the global variable. Let me show you. The offset that I need here, according to the geometry, should be equal to variable C. And variable C is 3mm. So I put 3mm here. So let's put 3 and click on OK. Now you can see this dimension, right? Double click on it, and here we can define the global variable. Here we can click on equal, and then you can see global variable. Let's choose C, click on OK, and now you can see this sigma sign, which is showing this is a global variable, and we are good to go. So now I have this geometry. But if I want to extrude this black surface, it will cover the holes, right? So I also need to define these holes. In order to define the holes, you can click on a sketch, and then from the options, click on Convert Entities. Convert Entities helps you to make a sketch from the feature you already have. So I click on a hole, and I click on this hole and click on OK, and now you can see I have the sketch. So now the sketch is ready, everything is ready, we can extrude this sketch. Let's click on Feature, click on Extruded Bus, and again for the thickness or height of this section, it should be equal to variable C. So what I can do, put equal, and then from the variable you can choose variable C, click on OK, and that's it. That's the second part. Okay, awesome. Next step is to make 3 buses on this feature. So what I can do, I can click on a sketch, I click on the sketch command, and I choose this top surface. We need 3 buses. In other words, we need 3 circles. So from the sketch, I'm going to choose circle command, and then here I make 1, 2, and 3 circles. Now, according to the geometry and the drawing, the diameter of these circles must be 16mm. So what I can do, I can click on the Smart Dimension, and here 16mm, 16 and 16. Okay, same as before, because we need to keep the hole, we need to define the geometry inside the circles as well. So what I can do, again from sketch, I can choose convert entities. I click on the circles, click on OK, and now I have the holes. Now it's time to use extruded boss feature. So click on feature, click on extruded boss, and here we need to define the height of these bosses. According to the drawing that we have, the height or the distance of the surface of the bus to the bottom surface must be equal to variable b. So what I can do, from the options I have, I can choose offset from surface. And then the reference surface would be the bottom surface, so I select it. And here for the distance, I'm going to choose variable b. So put equal, and then from the options, you can choose variable b. Okay, but we don't see anything here, so most probably the direction is wrong. So what you can do, just click on this reverse direction, and now you can see the extruded boss. Click on OK, and we are good. So now we have our geometry shown here. If you have doubt about the height, or you think maybe it could be wrong, you can simply go to Evaluate tab, click on Measure, click on this surface, rotate the part, click on the bottom surface, and now you can see the distance is 18 mm, which is equal to the variable b. Okay, so last step is to make the cutout from the bottom surface. If you look at the bottom view and also section view, you can clearly see that we need 3 cutouts here as well. So let's make those cutouts. In order to make those cutouts, we can click on a sketch, we click on a sketch command, and we select the bottom surface. Now we need 3 circles, so let's make first one, second one, and third one. Now according to the drawing, the diameter of these circles must be 11 mm. So I click on a smart dimension, I choose 11 mm here, 11 for this one, and finally 11 for this one. Okay, now it's time to use extruded cut feature to make our cutout. So to do this, I click on feature, and from the options I choose extruded cut. Now here we need to decide what's the depth of these extruded cuts are. Now looking at the drawings, we can see that the distance between the bottom surface of the cutout and the top surface of the bus should be equal to 2 times variable c. So let's define that dimension. So what we can do here, we can choose offset from surface again, and then I click this surface as my reference, and the distance must be equal to 2 times variable c. And then you can see the preview, click on OK, and now we have our cutout. Okay, awesome. So now we have the geometry. It's time to check the total volume or mass and make sure that we have the correct geometry. So this question is a little bit different. If we go back to the question and check the question, we see that they actually defined a material in this question, and we need to check the total mass, not total volume. So let's take a look at this question again. As you can see in this question, they define a material to be PE low or medium density, and you have the density. So let's add material to this geometry and then check the total mass. You can see we have the total mass provided here. So let's go back to SolidWorks and add material. In SolidWorks, in order to add material, you can simply choose the material from model tree, right click on it and edit material. And now here you have the list of materials. We don't need a steel, but we know it's plastic, so click on plastic, and here you can see PE, low, and medium density. Double check the density to make sure it's exactly the same as what's shown in the question. It should be 917 kilogram meter cube, and we have the same density. Click on apply and then close it. You can see that the color of the geometry changed, which means that you have the material assigned to it, and you can also see the name of the material here. Now that you have the material assigned, it's time to check total mass. Let's check total mass. To do this, click on evaluate, click on mass properties, and here you can see the mass that we have is 38.7 grams. let's check out the mass in a question. In the question, as you can see, the total mass is 38.7 grams. This is exactly same as what we found, which shows that our modeling is correct. There's no issue with it, and that's a final model for us. Now, just to practice and learn how to deal with the variables in the geometry, let's update our geometry with the new variables, because as you can see, this question has 3 sections. We solved section A, we found the correct answer. Let's try section B, for example. So to do this, we need to change the variable from 43 to 46 for A. For B, we need to change it from 18 to 16, and for C, we need to change it from 3 to 2. Let's do that. To change the variable, you can simply go to equation, right click, and manage equation. And here, let me just move this because I want you to see the geometry. Okay, so now I'm going to change this. So they're asking us to change 43 to 46. They want us to change 18 millimeter to 16. And also they want us to change variable C from 3 to 2. Okay, now I click on OK, and you can see that the geometry was automatically updated. This is a nice part about using variables. You don't need to go back to your sketches and then modify it manually. You can simply change the variable and SolidWorks will update the geometry for you. Okay, so now we have the updated geometry. Let's click on mass properties. But before that, let's check the mass, total mass that is provided in a question. In the question, you can see that the total mass for section B is 30.56 grams. Let's go back to SolidWorks and check our total mass. In SolidWorks, in order to find mass again, we click on mass properties, and you can see that the mass that we got is 27 grams. It should be 30, so something is wrong with our geometry, or maybe with the global variables that we defined. So unfortunately, we have to check it and see where that problem comes from. So let's take a look at each of the features that we have and try to find source of the issue. Let's just start with bus extrude number 1. So here I can click on it, bus extrude number 1, and then I click on edit feature, and you can see that for the thickness we have global variable used for the thickness. You can see that it's 2 millimeters, so this one is okay. So I click on OK, then click on the arrow, and now next we need to check the sketch. Click on edit a sketch, and when you click on edit a sketch, here you can see that we have the problem. So as you can see, we have a fixed dimension for the diameter of this circle. It's 86 millimeter, but we know that this dimension must be an equation-based dimension. We should have sigma sign beside it. So something is definitely wrong here. Let's double click on this dimension, and as you can see, it's a fixed dimension. So for some reason, I'm not really sure why, we made a mistake. So what I need to do here is to define the diameter of this circle. To do this, simply we can put equal, and then from the variables I'm going to choose A, multiply by 2, and hit enter. And now you can see I have 92 millimeter as the dimension, and more importantly, you can see the sigma sign, the red sign that you see beside 92. That means that this dimension is equation driven. So now this dimension is fixed, and hopefully this is the only issue that we have in this model. So let's update the model and then check the mass again. So I click on this arrow on the right side, and now the geometry is updated. Let's click on mass properties. And now here you can see that the total mass is 30.56 grams. This is exactly the answer that we were looking for. So we made a mistake, we found a problem, and now everything is okay. Just remember, whenever something is equation based, we must have sigma sign beside it. If you don't see it, then definitely something is wrong, like a mistake that I made here. So now I think we found the answer. That's it, and we showed you how to find a problem and how to fix the issue. Okay, great. I think that's it for today. I hope you guys enjoyed this video. I know that this was not a typical video. Most of the time we just follow the question that we have in PDF, but as I explained, this question was a little bit different. We didn't have an important dimension, and that's why we found a new question which was more completed, and then we used that question, the dimensions that we had, and then we modeled the part. But this was a good opportunity for us to practice equation-based modeling and also assigning material to the model. So I hope you guys enjoyed this video. If you have any feedback or comment, please leave comments down below. Thanks again for watching. My name is Ruzbe. Hope to see you again soon in the next videos.